All right, today we're going to tackle one of Go's most useful and, let's be honest, most debated tools, Go Generate. If you've ever found yourself just hammering out the same boilerplate code over and over again, well, you're going to want to stick around for this.
You know, to really set the stage, I absolutely love this quote from Nick Toby. It kind of says it all, right? If you want to start a shouting match, ask if generating source code is a code smell. It's hilarious because it's so true. Code generation has this reputation, and people have some strong feelings about it.
And look, let's be real, that stigma isn't totally out of nowhere. Generated code can be ugly, it can be hard to debug, but what's the alternative, really? Writing mountains and mountains of repetitive code by hand. And that, right there, is where the real danger lies. One tiny copy-paste error can introduce a bug that takes you hours to track down. So in those cases, letting a machine do the boring stuff isn't just easier, it is so much safer.
So this is the exact problem that Go's own tooling sets out to solve with a very specific and very deliberate answer, the Go Generate command.
I think the best way to really wrap your head around Go Generate is to first understand what it isn't. It's not trying to be a replacement for a big, heavy build system like Make. As you can see, Make is a whole thing. It does dependency analysis, it has complex rules. Go Generate is pretty much the opposite. It's just a simple command runner. And that's not a weakness. That simplicity is 100% intentional. It's a feature.
Okay, so if it's really that simple, how does it actually work? Let's peel back the layers and see what's going on under the hood.
I mean, it really boils down to just these 3 simple steps. You find a Go source file, you add a special comment to it, you tell it what command to run, and then you pop open your terminal and type Go Generate. That's it. The Go toolchain handles the rest.
And this is the magic little spell right here, the directive/go generate, followed by whatever command you want. Now, this is super important. The syntax has to be exact. It has to be at the very start of the line, no space between the slashes, and Go Generate. When you run it, that command gets executed right inside that package's directory, so it has context and access to useful environment variables like $go_file, which is the name of the very file that comment lives in.
All right, let's pause here, because we're about to get to the single most important philosophical point about this tool. If you take away just one thing from this whole explainer, make it this.
Here it is. Go Generate is a tool for package authors. It is not for the clients or consumers of your package. This is the core concept you have to grasp.
So, what does that actually mean for you day to day? Well, it means that Go Generate is totally intentionally separate from Go Build or Go Install. Someone who uses your library should never, ever have to run it. And that leads to the most critical part. You, the developer, run it manually, and then, and this is a must, you check the generated files into source control, like Git. This is what keeps everything simple and secure for your users.
All right, enough theory. Let's make this real. We're going to look at a classic, super concrete example to see how this all works in practice.
So this example actually comes straight from Rob Pike's original blog post on the topic. Imagine you've got a set of integer constants that are basically acting like an enum, in this case for different types of pills. When you're debugging, you'd want a nice human-readable string for each of those values, right? Of course you would. The manual way? Oh man, you'd have to write this huge, tedious string method with a giant switch statement like you see on the left, and every single time you add a new pill, you have to remember to come back and update this thing. It is just begging for bugs. But with Go Generate, you just add one clean single line, a directive that calls a handy tool called Stringer. It does all that tedious work for you.
And this is what Stringer spits out. Yeah, it might look a little ugly, maybe even a bit scary, but that's the point. You're not supposed to touch this. This code is written for the machine, not for you to read and edit. But look closer, it's actually doing some really clever stuff with string slices and indexes to create a super efficient mapping from the integer to the string. And it's guaranteed to be correct every single time you run it.
And Stringer? That's really just the tip of the iceberg. This whole Go Generate pattern is the backbone for some of the absolute most powerful tools in the entire Go ecosystem. We're talking about generating gRPC and protocol buffer code, creating test mocks with MockGen, generating completely type-safe SQL code with SQL-C, and even scaffolding out entire servers from open API specs. It's everywhere.
Okay, so this brings us to a really important point about how the whole ecosystem has evolved. Because for years, there was this one nagging problem with using Go Generate. For the longest time, the nagging question was always this: how do you manage the generator tools themselves, right? How does my coworker
or the CI server get the exact same version of Stringer or Machchen that I just used. Trying to keep everyone's tools in sync was a huge headache.
So for a while, the community came up with this workaround called the tools.go pattern. You'd make a special Go file, put a build tag on it so it wouldn't get compiled, and then you'd import your tools. This kind of tricked the module system into tracking them. It worked, but it had some major downsides. It bloated your go.mod file with dependencies your actual application didn't use, and running the tools with Go run was slow because it couldn't be cached.
And then, Go 124 came along with a much cleaner solution. Just look at the tiny but powerful change on this slide. We went from using Go run in our directive to using Go tool. It seems small, but that one-word change signals something really important to the Go tool chain.
And this is the final piece of the puzzle that makes it all work so beautifully. Go 1.24 gave us a brand new tool directive for the go.mod file itself. You can now declare your tool dependencies right where they belong, cleanly and explicitly. This keeps your dependency graph pure, it's now the standard way to do things, and it finally solves that tool management problem for good. No more weird hacks.
All right, let's wrap this up with the key takeaways. If you remember anything, remember this. Use Go generate to kill repetitive, error-prone boilerplate. Never forget the golden rule. It's for you, the package author. That means you always check your generated code into version control. And finally, if you're working on a modern project, please embrace the Go tool command and the tool directive in your go.mod. It's the way to go.
So I'll leave you with this question to take back to your own code. What tedious, repetitive, and just plain annoying code are you still writing by hand that could be completely automated away, just by letting the machine do the work for you?